Good evening, everybody. Thanks for sticking around. And if you don't like this session, you can go home. And if I see only one person sitting, I'll go home too. My name is Vaagn, and here's Tigran.
My name is Tigran Gevorgyan. Thanks for coming.
So today's talk is about FTP Time Bandit. That's a tool that Tigran developed, and we thought about having another go on a good old get flooding. So who we are Vaagn, Toukharian, and Tigran Gevorgyan, work for Qualys. We break stuff, as all of you guys do probably, and sometimes we fix stuff. We are into time travel, which we talk about in a little bit, and we both love to try, meaning we run fast, we swim fast, and bike fast. So if you start heckling us, we'll run away. So, well, we're gonna talk about, as I mentioned, we're gonna talk about application layer denial of service attack methodology, and a tool. We will show you some stats. We will then go into a little bit of defense and some use cases and usage possibilities for the tool. Why do we do this? What's the reason behind all of this circus? Is because we wanted to have a time machine. We tried to buy it, and we found one on eBay. It looked like this. And then we figured it doesn't gonna work, and then we invented our own. The time machine that we have does one thing. It kind of goes into the future and then calls back to us and says what's gonna happen to your web server. So that's what we have now. So before we show you the tool and talk about the tool or method, let's go a bit into the taxonomy of the denial of service. So denial of services are, if they are not on the resource consumption side, they are striving to crush some stuff, degrade IT infrastructure capabilities. The second type that goes towards usurping the resources, usually does it on a network resource, network layer, tries to get as much connections as possible or something like that. Infrastructure based denial of services are trying to flood infrastructure, network infrastructure, or databases, or something else. And there are target resource exhaustions, which are on a network layer like SIM floods, or application layer that we are going to talk about, and then more advanced business logic layer. So classical application layer, layer 7 DOS or DDoSes are, for us, divided into two types, subtypes. One is DDoSing blindly or semi-blindly. It's just getting, basically doing the GET request over and over on the index.html or some other resource. Some more advanced guys do that from thousands or 10,000 of bots simultaneously. The cons of this method are there is no feedback, and then the load on a client and server is almost similar or near similar, so it's a near symmetrical load. There is a new breed of DDoS tools, a type that is called slow STAR, slow load, slow HTTP test, slow read. Those guys are more of a asymmetrical by nature. they try to exhaust resources on the server side, while client side doesn't really suffer a lot. And like, for example, the slow HTTP test is basically doing HTTP post or GET, where it's mostly post, where it is sending large data, but trickling that data in and basically just hogging the connection, the file descriptor or socket descriptor on the server end. There are a few other types, like PKI abuse, where you renegotiate over and over and over and run the server end into consuming more CPU resources than you. SQL wildcards could be used to cause the backend SQL server to think a lot and churn lots of CPU time and disk time and disk usage. And there are brand new HTML5 lovely WebSockets connection hogging issues. Basically, WebSockets by nature are like whatever slow LoRis or slow HTTP test is trying to do. They are connected all the time, so each WebSocket connection hogs a file descriptor or opens up a port and sits on it on the server side. So its misuse, WebSockets could be very dangerous for dosing or DDoSing. I'm sorry.
When you mentioned the asymmetrical load,
Yes.
would you try to say that line is actually experiencing the same load as server?
Near symmetrical, it's not the same, but it's near symmetrical, yes. And as compared to the new smarter bots, this is very asymmetrical, where your clients are almost not doing anything, but the server is limited to some amount of resources and you're hogging it. Some very exotic, since we have a very small family-like situation here, you can stop us and ask questions anytime. Or if you don't like anything, throw something at us. We'll throw it back. So some exotic layer 7 DOS methods are, as we talked before, the DB, wildcard abuse. And imagine that with a genetic algorithm that figures out which payloads or which wildcards get more server stress. Those could be very interesting and exotic types of stress. Some new layer of above layer 7 attacks, business logic attacks. Examples could be adding too many things on a cart for e-commerce website, and then that application logic of that site is gonna suffer or slow down or crash. A few other examples, logging too much. I mean, not causing logging system to log too much and run out of disk space or something like that. So what is our proposed method is not exotic. It's not one of those that we just mentioned. It's not one of the slow HTTP tests or slow LoRis or slow GET attacks. And it's not trying to exhaust this magical 20K HTTP connections limit. That's not the intention. So what we think is resource consumption is asymmetrical by the nature if the client is not full-blown, it's not a full-blown client, basically. It's not running JavaScript, it's not trying to render everything, it's just requesting. Then server is going to suffer more, everything else being equal. So what we propose is just a regular get plot for those who remember that, coming from the first day of internet, web probably. And what we do is just add some more analysis before you go on blindly do a bunch of GET requests.
Right. So I'll take it from here. So the method, this time machine idea that we had, right? Imagine if you're playing a roulette and you know beforehand which slots the ball is going to land on. That's going to give you an advantage. So this is the same kind of idea. First you analyze the website and you identify the resources that are what we call heavy, and you start flooding them with those, especially those resources, and hoping that that will bring down the website. So the idea is actually very simple. We spider over the website, we gather all the resource download times, for example, and then that gets us a lot of data, and then we use the mathematical approach to these statistics to handle a lot of data. So we take the measurements, take the mean of the measurements, and that's how we start classifying resources there. So, for example, this is a scan of a website. You see typically some resources are fast, some are slower, but they are grouped in some categories. So the group on your left is the slow resources, and I mean they are significantly slower than the majority of other resources, so it bears further investigation. So as I described, the formal method kind of is we take a measurement over all resources of a website, then we calculate the mean. We selected the mean as the measure of center dependency. Then we calculate the standard deviation on those. So this is to eliminate the resource measurement that is not constant enough, that is fluctuates based on some other like caching techniques or something. And so then we just sort the resources by their means, and we start looking at the top of the list. So I'll get back to this slide in the demonstration. And so now give me a second to run the video. Okay, full screen.
He's a full-time Linux guy, so he hates Windows.
Yeah.
He may crash it.
It's not getting full screen, right?
Yeah. Wait.
Oh, okay. Play it first. So here, in this example, I'm running the tool against a locally hosted website, and I specified the depth of the crawl, number of measurements to take, and it presents a list of URLs and sorted by their time. So it can be instructed also to generate an XML as the output. We selected XML because it can be fed to some other tools, and I'm sure people can come up with some clever ways of using this data. So here we see the measurement and the measurement data, for example, the mean of the download time and the standard deviation. So the ones that have higher standard deviation can be thrown away. And this tool also has ability to measure by start to download time. So you can actually evaluate resources with both criteria, and that will give you a better idea of what the heavy resource is. Because it may be different why the resource is slow. So this is a visualization XSLT that allows, based on the XML that is generated by the tool, it draws this chart, and so this chart helps us understand what the resources are. So there are 4 quadrants here, and the top 2 quadrants have resources that are unreliably measured. So we throw them away. Instead, we concentrate on the bottom left quadrant, which are slow resources, and they are consistently slow. So it is in these resources that we need to find the ones that we call heavy. We need to concentrate in the quadrant, and the closer to the origin the resource is, the better or worse in performance terms its behavior is. So yeah, we can just concentrate on top 10% of these resources and start testing those. There is another visualization method that this tool affords, and this is, graph-physics.language. It generates the graph of the website in .language. So this is, right now, it's not very, very useful, but again, in future, someone might find something useful to do with it, and it maybe highlight, heavy resources somehow. So once you have guesses about the resources, right, what can be done using this tool? And the idea is that we can test it against, for example, right now I'm running a test against content management system, Concrete, and I specified again the URL, the depth, how many measurements to take, and it will come back with the resources that it thinks that should be tested, should be further tested. And just by looking at this list, you can start having ideas, for example, why a resource is slow. Maybe it had to do a DB access, and that's why it's slower than, just about box. So you start getting an idea of what to do. So what can be done also with this tool, the XML that gets generated by the tool can be fed back into the tool to test this guess that the resource is really heavy. So you give the, as an in parameter, you give the XML, and then it will run the test again with more number of probes. And it will return, say, previously it was, the measurement was 10, now it went back to 12, so, let me just pause this for a sec. So if the performance degraded, that means that the guess was right, that this was really a heavy resource. Otherwise, this delay in resource presentation may be caused by load balancer or something. So this tool allows us to kind of come up with best guesses. So let me explain what's happening here. So this part is supposed to demonstrate the asymmetric nature of this attack or test, if you will. So there are three screens. I separated into three screens. The top screen is running top command on a web server. It's an Apache web server on a 8-core machine, I think. And then the bottom right one is top command running on my machine. So right now it has about 9% CPU, and this was done with the recording software. So the recording software took 9% CPU time. So, and then the bottom left, I'm going to launch some tests to kind of stress the server. So we see that, yeah, the server right now has 0 CPU load, and I'm launching the tools 3 times, and the load on the server climbs up to 80%, and then the load on my client goes only to 9%, which is as Vaagn was saying, the asymmetric nature demonstrates the asymmetric nature of these tests.
Yeah, actually, the load on the server is 99, including the system.
Oh yeah, yeah. So I mean, it's overwhelming, and you achieve this by carefully selecting the URLs to attack rather than attacking everything. And I'm saying attack because it can be also replaced by testing, because this is valuable for testing as well. So this is an example of testing. So the CMS here that was chosen again is Concrete 5, and then there were 3 instances of the tool launched. Each one does only 100 probes, and we can see that the server performance degrades over time, and which proves that the resource choice was guessed actually correctly. I think, yeah.
So we didn't want to reinvent the wheel, so we looked at other tools to see what other guys are doing. There are tools that do similar stuff. from the testing perspective. Some tools do the statistical analysis, like the first tool in the list, do HTTP. But none of those do really, none of those does really do the same packaged functionality as the tool that we presented. A few interesting things about the tools listed here. Tsong is Erlang-based, very powerful stress simulator, stress tester, can scale on the clusters of machines and it's known to generate up to 1 million concurrent requests, HTTP concurrent HTTP requests. The tool called Pilot is very close to what we have, has the statistical analysis of some kind, but it does lack this parallel testing and load measurement during the attack-like stage, and it doesn't have the crawler. But using any other crawler, one could create a flow using Pilot as the consumer of the crawled list and run statistics on it, if they really hate our tool. So what do we do? How do we defend against this? We call Master Jedi, Master Yoda. And it's really hard to defend against DDoS, but against those, some things could be done. If it's layer 7 DOS and it's not one of those exotic ones, it's just a get flood, there are ways you can fight with it. Load balancers would be one of the good propositions. One could use our tool to figure out what's the problem in the first place, and they could eliminate the resource hogs. We will go through a couple of Apache configurations and Apache modules that could be a good solution. And then we would suggest a very good Apache mod security protection mechanism that we were too lazy to implement. But all of these, again, could fail if the attacker is very resourceful. If he knows he's dealing with a system that is being protected with one of the above mentioned methods, except solving the problem of resource hogging, they could play on right on a border of allowed stuff. We'll come back to it a bit later. So load balancers usually are good for this because there are some rate limiters that they can use, unusual traffic filters and source checks. Possible issues would be if the backend IP address is discovered, then load balancer becomes non-operational. Attackers can go directly to the backend if backend has a public IP. Load balancers can't really know what is the real load on a server, on the system, because they don't look at the resource consumption on a backend server. And as I mentioned a minute ago, if attacker senses that the protection is implemented, they could perform the attack right under the threshold without raising the suspicion of the protection services, or basically kicking in the protecting method. And some methods of defense are based on looking at the similarities or detecting the way the packets or requests are formed. Attackers could mix it up and fool the protection system. One good suggestion is HA proxy. not only will help with setting up different policies that are setting thresholds, resource limiter policies, but also they would be, HA proxy implementations would be helpful to divide up your resources into static and dynamic sorts, and you need to really push that very low thresholds only for dynamic stuff and let the static content be more freely available or have a different request rate. Besides being a load balancer, HA proxy has the natural way of protecting your backends if you have more than one backend by just load balancing. So what about commercial protection services? There are cloud-based security as a service, software as a service solutions for this. Most of them do the same as load balancers we mentioned, or protection modules that Apache could have, usually are resource rate connection originating IP limiters. Some of them also have nice features that they also will protect you from slow start type attacks, for HTTP test, for HTTP read. And as additional bonus, they would throw in more security-like features to protect you against SQLI and XSS. Problem with those services, they are costly. Good service is going to be upwards of $150 per month. We talked to a couple of users of those services, real users, and they complained by literally saying, I quote, would not use the full-blown solution because don't want to degrade the user experience. Because usually commercial protection services, those protection services usually slow down stuff on a first connection, will require CAPTCHA or something else. And there was a good talk this year in this year's Black Hat about DDoS mitigation bypass. So basically, to reiterate, it's basically playing right under the threshold, mixing up stuff, and basically fooling the protection services. And all the paper says that almost all of them, the major ones, get fooled easily. So saying that, we suggest that an owner of a large web resource or web resource that has a asymmetrical load between its resources runs our tool or any other tool to figure out what are, basically use it as a QA tool, figure out what are the resource hogs, and basically take them out. For that, they can also, since it allows you to tweak with the XML, you can also change parameters, make it more stressful for the server, and basically think as a hacker and use the tool to figure out what will happen. In an ideal world, if we weren't too busy or too lazy, we would generate some config files for Apache modules that could protect, or for HA proxy. But to be honest, we don't even know what to choose because it depends on your situation, so we can't really suggest a universal silver bullet. So we, as Tigran showed you the concrete CMS that he basically overwhelmed with 3 threads running top resources over and over. And we did try to do the same thing, but provide some protection and see what's happening. So the baseline was something even worse. It was like one client running 10 parallel requests 3% CPU utilization on the client machine. Server is 98%. This is very high-end server, struggling. So using standard Apache configuration directives, nothing could be done. If you guys can figure out something, that would be grateful. That would be great. We will be grateful because that makes things a lot easier. We can just provide a Apache config suggestion, and people are cured of all the DOS. Then we tried going through some modules that will be helpful. Mod security comes into mind right away when you want to protect your Apache. Some directives help here. They are a bit crude. You can set it up and like limiters per IP, and you get the bad guy throttled right away, and CPU usage goes down to 0. But this is too crude. Wouldn't recommend it. So the advanced mode security protection is the part that we said we are lazy and we didn't implement, but this would be the best solution probably, because it's gonna be tied to the real web server on a server side. It's gonna feel the pain of getting hammered. It's gonna know which resources are most heavy for him, and it's gonna set different thresholds for different resources. So it's not gonna cut everything with one cookie cutter. Still in a theory. Coming next year, maybe. So another module, very crude, very fast. It works just by setting the maximum connections per IP. As they say on their website, this module is not designed to prevent denial of service attacks. They are right, because this is very crude. You can't just limit by IP. ModQS, it's a bit more controllable, has more features, basically does the same as the previous module, but can also protect against slow star attacks. This guy is the trickiest of all of them, very hard to configure, but it's very rich. So you could really generate specific settings for your application by running it in a test mode, and generate, and you can figure out what the thresholds that you need to set. It's tricky, but it's also very interesting. You can set up these settings that are based on this idea of depth and credit, so you can let it accumulate some incoming traffic all the way up to some depth threshold, and it's going to be more elastic. It will let you have this spontaneous traffic coming in, but if it sustains, it's going to kill it. So it's less straightforward, but more useful. More useful for real web apps. This module was promised to be the one that really looks at the resource consumption, that really looks at what is going on with the server, but discontinued. We couldn't make it work with modern Apache servers, and that's why this green and angry guy over there, because that day we were also green and angry, couldn't get it work. This one, Modivasive, is the Superman. It works well, really easy to set up. The 3 directives, you set it up, it works. If you're gonna go with limiter, This is the one. Easy to build, easy to install, easy to set up. So if we would go into this road of setting up one of these modules and hoping it works, then we need to make sure they don't interfere with protection against these popular slow start attacks. Our favorite module, Mod Evasive, is not protecting against slow start attacks, but it also is not conflicting with it. So you could then come up with a slow start attack mitigation by using Apache, regular Apache directives listed below. And then there is this very interesting module. It's a bit wild, hence the Ranger. What it does, it's not for DOS attack mitigation, but it can be used for it in a very interesting way. It can get honeypot, project honeypot data and get the list of offenders, and then one could use the list of offenders using another module and block those IPs. Let's talk about the usage, recommended usage. So we recommended that we use this tool as a QA tool, find out the resource hogs on your web app, and take care of them. Of course, it could be used for bad. The last portion of Tigran's demonstration was almost the essence of the bad usage, where you stress tested it with parallel analyzer attacker mode. And of course, it could be used as the bad times many, and we know what happens then. So let's go back to what we have and what's going to happen. We want to understand, get a better understanding of what tool would get when it's used against the targets that are behind load balancers. So far we use it with HA proxy, we have some ideas, but it's not full analysis. SQL wildcard usage, one of these exotic attacks could be embedded into stress testing. If we find forms that take some arguments that could go into SQL, we could try to leverage that and get more stress with SQL wildcard. State reset cost could be looked at to see if it's going to be pricey to force the server to generate session IDs over and over. And the automated attacker and service degradation measurement that Tigran showed could also be enhanced and could be more stressful, sort of. So that's all we have, and we have released the tool. It's on a GitHub. You can download it, play with it. The presentation, which is going to be on a website, I think, has all the references to all the tools or papers mentioned. And we'll take some questions.
When you analyze load, you use response, correct?
We
use response. The kind of response, and you assume that this is flow URL, correct?
Mm-hmm.
What about the situation if you have, is it possible that the queue will go up, but the response will still fast or not? Because sometimes you don't care about the response, you don't care about the queue.
Yeah, yes. So you're saying that it could fire back the request and then do something on the CPU. Let's say you said insert something into SQLDB and response comes back, I'm done. It was real fast, but that insertion or deletion takes CPU and
Because I've seen creation different systems where you can, CPU is normal, but the response is slow. Sometimes it can be the response is decent, but CPU is very high.
yeah.
I mean, not always the response is high.
Sure. So that's why this parallel analyzer, attack analyzer mode is making sure when you stress it more, it becomes slower, which means it's not delay that is arbitrary delay, say, to sleep or something else. It's really slowing down because the server is overwhelmed. But of course, those resources that are going to be CPU hogs or DB hogs, but answer right away, we won't detect them.
And it's unlikely that it will detect HTML based, right? It's something dynamic, something content.
Yeah, we don't really care if it's static or not. I mean, we don't assume it's static or dynamic. We look at the log.
Because static, even very large HTML page, it takes only, it cannot take the server down.
Right, right. That's kind of this. Let me show you this one. So that's why when you take overall baseline of the entire website, right? You know that some behave in some way. Here I tagged some of them as normal, and majority of them are maybe static pages, maybe some resources, CSS and whatnot. And then some are markedly slower. So then it bears, further investigation. Why is this happening? So this is what this tool is trying to do, to kind of throw away the majority and allows you to concentrate on the 10% or whatever it is that is interesting.
What's the authentication? For example, the website requires authentication.
Tool cannot do authentication, and I think right now it can't even replay a cookie or do HTML. I mean, HTTP header injection of some kind, but that would be one way to embed. So it's not. We're not supposed to advertise anything, but Qualys has similar tool embedded in their scanner that does the authentication and then does the attack. So this is a community tool. There's a.
But I mean, there's underneath curl is used, so we could add authentication. So that's good feedback. Thank you.
We still have time. Can take questions. Any questions about anything? All right, then we won't take any more of your time. Thank you.
Thanks a lot.